Hello everyone, welcome to Penguin Paleontology. Let's get into the last eon that falls under the Precambrian, the Proterozoic Eon. If you remember the last video, we covered the Archean Eon. We discussed how the first continents formed and how life got its start. For those who have not watched the Archean Eon yet, I encourage you to watch it. That way you are all caught up to watch the Proterozoic Eon. The Proterozoic lasts an unimaginably long time, a daunting approximately 2 billion years. During this time, we see great diversification of different species, and along the way, the first multicellular animals. The Proterozoic Eon is the third and longest eon of Earth's history, spanning from 2.5 to 541 million years ago. The Proterozoic is known for the origin of non-microscopic life in the Ediacaran, an era of the Neo-Proterozoic. But there is so much more. Snowball Earth, an extinction by too much oxygen, and glaciations 2 other times. The Proterozoic is divided into 3 eras: the Paleoproterozoic, the Mesoproterozoic, and the Neo-Proterozoic. The Paleoproterozoic is the first era of this eon. It is also the longest era of Earth's history. It is approximately 1 billion years and contains 4 periods: the Siderean, Rhyasian, Orosirian, and the Statherian. The Mesoproterozoic is the middle era of the Proterozoic from 1.6 to 1 billion years ago. This span of time is famous for the breakup of the continent Columbia, the formation of the continent Rodinia, and the evolution of sexual reproduction. The Neo-Proterozoic is probably the most important out of all 3 eras, because this is when life's first minor diversification occurred in the Ediacaran. The Great Oxidation Event happened in the Paleoproterozoic era. For a few hundreds of millions of years, cyanobacteria during the Archean had been taking in CO2 and letting out oxygen. After a long time, there were no groups from the kingdom Animalia to take in oxygen and let go of CO2, so there was too much oxygen on Earth. Too much oxygen is actually toxic to cyanobacteria because they evolved at a time on Earth when there was no oxygen. This caused the first extinction. At the time, Earth was precisely the same temperature as today, even though there was a 5 to 18% weaker sun. It's called the faint sun paradox, and it states that while the sun was much weaker than it is today, the atmosphere was much less dense at the time. This means that more light can get through Earth with less of the atmosphere blocking it. After the Great Oxidation Event, we see the first eukaryotes, cells or organisms that have a clearly defined nucleus, evolve, allowing the cyanobacteria to gain back their CO2 abundance. The Earth wasn't even done trying to free itself from the cyanobacteria that had accumulated over the last billion years. The Huronian glaciation, also called Snowball Earth, was a period of time when the entire Earth literally froze. This wasn't even close to the conditions of other ice ages. It started in the Rhyasian period in the Paleoproterozoic and is divided into 3 different events, unlike one event which it is most mistaken for. The Earth took a long time to recover after this catastrophic event, but following this event, life pushed on. The Boring Billion was a time from 1.8 billion years ago to 800 million years ago. You're probably wondering why it has that name. It's exactly what it sounds like. It is a period of time when the world was just recovering from the Huronian glaciation and the Great Oxidation Event, a world that lacked nutrients and became stagnant for a billion years. Other than the formation of the ancient supercontinents, Columbia and Rodinia, the continents weren't even moving around much, despite all the boring things that are happening. The Boring Billion was a really important time in Earth's history. It is responsible for the emergence of eukaryotes. It is unknown how exactly eukaryotes emerged, but the process and result was really one of a kind. But when they finally did emerge, the cyanobacteria had taken over the world again. This might be the first time when the action pressure of another animal drove another animal to evolve and adapt. The eukaryotes also adapted a number of traits that hadn't existed at the time, such as sexual reproduction and organelles. We don't have much evidence of the climate from this time because there's a limited amount of rocks and fossils from this time. When a lot of people think of the subdivisions of the Proterozoic, they think of the Paleoproterozoic, the Mesoproterozoic, and the Neoproterozoic. If they wanted to be more specific, they would think about the Ediacaran, or maybe even the Cryogenian. But there is another mostly ignored division of the Proterozoic called the Tonian. It spans from 1,000 to 720 million years ago. So, why is the Tonian important? In the Tonian, two notable things happened. One, the core solidified. And two, the first multicellular animal appeared. The core solidification isn't really understood, but it helped stabilize the tectonic plates that were floating around Earth with massive speeds. The appearance of the first multicellular organism was a major milestone in the slow road to the evolution of life. The animal was a sponge, and even though it lacks complicated body systems like the circulatory system, it is still classified as closer to an animal than a plant. It was named Otavia antiqua, and its fossils dated back to about 1 billion to 550 million years ago. The Cryogenian was the second of the three subdivisions in the Neoproterozoic era. It lasted from 720 to 635 million years ago, and it was when the third glaciation of the Precambrian occurred. It was quite expansive, covering most of the northern and southern hemisphere, but finally cooled off at the end of the period. Scientists think organisms evolved eyes when animals needed a way to find a place where sunlight was shining through thinner ice in a glaciation. The term Vendian animals refers to any animal that evolved in the Ediacaran. The Ediacaran is the last period of the Proterozoic and is known for life's very first ecosystem and diversification. The life present in that ecosystem was extremely simple. They were all non-intelligent and soft-bodied organisms. But a huge difference from these ecosystems to later ones is that there were no carnivores. All the energy that animals got in the Ediacaran came from slurping nutrients from the sediment at the bottom of the sea floor. There were a multitude of Vendian animals, but we are going to go over the most noteworthy. First up, we have Dickinsonia. Dickinsonia is a soft-bodied, disc-shaped animal whose sizes range from about 1 millimeter to about 1.5 meters. It is really good at giving paleontologists a headache, mainly because we just can't classify it reliably. Once Dickinsonia was found, paleontologists started speculating on what kingdom it belonged to. Some people thought it was some algae. This is possible because some algae, like kelp, can be extremely large. It could also be a fungi. There are a lot of species of fungi that live in the ocean, and Dickinsonia could be a long-lost ancestor of fungi. But the real game changer came from an experiment that mashed up a fossil of Dickinsonia to detect any substances found in the fossil. They detected cholesterol. Cholesterol is most commonly found in animals. This means it's likely that Dickinsonia is an animal. Another interesting animal is Tribrachidium. This animal is known for its unique radial symmetry and way of feeding. Tribrachidium possessed a feeding habit that has never been seen in any animal other than Tribrachidium and its relatives. It is a stationary animal that lounges at the bottom of the seafloor and waits for small micropods to float into its mouth at the center of its body. It also has an unusual three-way symmetry that doesn't resemble anything close to the fauna of the modern world or any other prehistoric animal, as far as we can tell. That brings us to the first Vendian organism to be discovered, called Charniodiscus. This organism, despite looking like a leaf, is actually an animal and is thought to have filter fed on the seafloor. It was about 50 centimeters long and was composed of three parts: the holdfast, which anchored it to the sea floor; the stalk, which was just above the holdfast and held the front together; and the front being the leaf-like structure on the top of the organism. The Proterozoic is a really important step to the evolution of humans, because this is when the animals made their first step out of the primitive microbe zone, and life actually started to get more complex. The following period, the Cambrian, is where everything starts to get interesting, so keep your eyes peeled for that video.